Hello, Algebra 2 geometry students. This ought to be our last video for this unit, I would think, or videos. We'll see how long it takes. But this is about when you have expressions with a bunch of different radical terms, when you can add and subtract them, when you can multiply and divide them. Generally, there's two rules. There's a rule for adding and subtracting, which is right here. There's a rule for multiplying and dividing, which comes later. The adding and subtracting rule is pretty straightforward. You can combine these radical expressions if the two things have like radical terms. What that means, just like radical terms here, it means that everything is the same. Like the index is the same and the radicand is the same and the powers are the same. Everything has to be exactly the same. And say we treat the radical like a variable means like if this was 6x plus 4x, you would know that that equals 10x. 10x. It's like adding 6 apples and 4 apples, you get 10 apples. Here, the apples are x's. In this problem, the apples are square roots of 7. So we get, that's not what I want to do. So we get 10 square roots of 7. And I can do that. I can add the 6 and the 4 because this is, the index on this is 2 and the power is 1 and the radicand is 7. And the same is true of this one. Let me repeat that. You can only add these together like this if every part of the radical thing is the same. Same index, it's 2 in both of these. Same power, it's 1 in both of these. And same thing under the radical, which is 7 in both of these. So 6 roots of 7 plus 4 roots of 7 is 10 roots of 7. And we can do the same thing here. We have 1 cube root of 2 minus 7 cube roots of 2 plus 5 cube roots of 2. So you just add the numbers in front. 1 minus 7 is negative 6. Negative 6 plus 5 is negative 1. So it's negative cube root of 2. Negative 1 cube root of 2. And we would try the same thing with this one. So this one actually has two different things. This is the 5th root of 4x. And that's a 5th root of 4x. So those we can add, but this one is a cube root of 4x. So we cannot add this last term with the first two. So I do 6 and 3 is 9 5th roots of 4x minus 2 cube roots of 4x. Like I said, this cube root of 4x is all by itself, so it cannot be added. It's like not, this is not a like radical term to the other two because this one has an index of 3 and the other ones have an index of 5. So you can add the first two, but not the last one. Right, so what about these? So these appear to have different radical terms, like the square root of 2 and the square root of 8 are not the same thing, but the square root of 8 can be simplified. The square root of 8 is 2 root 2. So this term here is really 3. Why does that keep happening? 3 times 2 root 2 minus 5 root 2. 3 times 2 root 2 is 6 root 2 minus 5 root 2. Now you can see that they do have the same radical term. It's root 2. And I have 6 here minus 5 there, leaves me just 1 square root of 2. So this is the same rule as before, but you might have, if this radical can be simplified ahead of time, you might want to do that first. Actually, you have to do that first. You can't see how to do it. So roots of 3, I assume this one can be simplified. Square root of 48 is the square root of 16 times 3. Square root of 16 is 4, so that's 4 root 3. So this root 48 is really 9 times 4 root 3 minus 4 root 3. 9 times 4 is 36. And that gives us 32 roots of 3. So similar thing to the one above. You just, they don't look like, the radicals do not appear to be the same, but you should always check and make sure you can't simplify one of them. And if you can, what happens at the end of it? This one, I'm assuming the same kind of situation. Something similar is going to happen. Let's see. So these are cube roots. So if I want to take something out, I have to take out 3 at a time. So this one, the second term can't be simplified. But this one, the cube root of x to the third is just x. And the cube root of y to the fourth, I can take 3 y's out as 1. And then I get cube root of 2y. Right, I took out all the x's and all but one of the y's. And now these things are actually exactly the same. And so there's 2 of them. So it's 2xy times the cube root of 2y. There's like one of these things plus another of these things gives me 2 of those things. So that is how those work. We'll do the multiplying and dividing rule, and then I'll probably break this video. I'm guessing this is taking a little longer than I thought. So that's the adding and subtracting rule. They must have the exact same radical term. And we saw here, sometimes we can manipulate it so they do, but until they do, you cannot add them and subtract them. Multiplying and dividing, on the other hand, works as long as the index of the radicals are the same. The word indices is the plural of the word index. That's why that's there. So if I'm doing this little distributing trick here, I might say something like root 3 times x is x root 3. Root 3 times root 5 is root 15. And this is what I mean, where we can multiply or divide the things into the radical as long as the radicals have the same indices. Like the index of this one is 2, and the index of that one is 2. And since those are the same, I can multiply the numbers underneath them. I got 3 times 5 is 15. If one was a cube root and one was a square root, it's not as easy to do that. It's not impossible, but it's not easy necessarily. So I can do the similar thing here. I look at these, I see cube roots everywhere, so I can multiply the things underneath them. So I do multiply this by this. I get the cube root of y to the third. That's going to simplify in a minute. And I also get the cube root of 2y, and there's a plus in between them. And the cube root of y cubed is just equal to y. And now I think I'm done simplifying. Again, the important thing to remember here is that the index of each one of these is the same, 3, 3, and 3, and that's why I can do this. This is like a FOIL question, really. And what I don't want you guys to do is think, this does not equal 4 squared minus root 7 squared. You cannot do that. Don't ever do that. Put a big X on it so you remember not to do that. I hesitate to write it down even. Really, this is, the squared means times itself. So that's 4 minus root 7 times 4 minus root 7. Now we like FOIL, you get 16 minus 4 root 7 minus 8 root 7. Then root 7 times root 7 is the square root of 49. Nope, it's plus. They're both negative, so it's plus. Square root of 49 is really 7. 16 plus 7 is 23, so 23 minus 8 root 7. Ta-da. So there's a little bit of this in here, but y'all might have already known how to do that. But I wanted to reinforce again how much you can't do it this way. Don't ever do it that way. These are just some more problems like the previous one. I can knock these out pretty quick, I think. So just multiply them together. FOIL, 4 root 3 times root 3 is 4 root 9. 4 root 3 times negative 5 root 2 is negative 20 root 6. Root 2 times root 3 is root 6. Root 2 times negative 5 root 2 is negative 5 root 4. You know that the square root of 9 is 3, so this is really 12. Square root of 4 is 2, so this is really minus 10. Then I get minus 20 root 6 plus root 6. And 12 minus 10 is 2. And our rule before said if you were adding and subtracting these things, as long as the radical part was exactly the same, we can add the numbers in front. Here they're both root 6, so I can do negative 20 plus 1 is negative 19 root 6. And that's what this one turns into. That looks right. Okay. Similarly with this one, now it's just A's and B's, but that's fine. I'm going to multiply everything out. Root A times root A is root A squared. Root B times root A is positive root AB. Again, the index of everything here is 2, so I can multiply these things underneath the radical. Root A times negative root B is negative root AB. That's going to cancel out with this one. And then positive and a negative is a negative root B squared. Like I said, these two, positive root AB and negative root AB, are equals 0. Square root of A squared is A. Square root of B squared is B. And that's it. A minus B. Easy peasy. So 2 rules in there. The adding and subtracting rule, which works when they must have like radical terms. That's the only time it works. And the multiplying or dividing rule, which says we can multiply or divide the radicands, the things under the radical, as long as the index of each radical is the same. 3, 3, 3, 2, 2. So we'll do a little more complicated stuff if they're not the same in the next video.